Can you guys hear me?
Yep.
How are you guys doing?
Going down already?
Good. How you doing, Mustafa?
Good, good. Oh, very well.
Hey, man. How you doing? Can you guys hear me?
Yep.
How are you guys doing?
Going down already?
Good. How you doing, Mustafa?
Good, good. Oh, very well.
Hey, man. How you doing? Can you hear me?
Good. Okay. Can you guys hear me now?
Yep, I can.
All right. Gonna grab a microphone.
Hey, guys.
Hey, how's it going?
Hey, Andre.
Good to hear.
Hey.
Okay. That's not what you put. There we go. So, I just wanted to go a little bit high level administrative things to start off. First off, let me show you guys some of the stats. Are you guys having trouble hearing me?
No, actually, you hear you loud and clear.
Awesome. Video.
Hey.
Screen.
Oh, actually, I forgot to put
Yeah, you see it too. So there's a stat bot on this Discord channel. I'll show you guys some of the stats. When we kind of made a goal to kind of hit a certain threshold at this point. I don't think we're quite going to hit that threshold, but I think I might as well address why and what kind of shifted that made it less of a priority. So there's a bot on the server that tracks a lot of the messages and things like that. User members, this is kind of how we've grown the last couple of months. We kind of hit our big peak around mid-May, and then we're supposed to do like another big push, but that push never really happened. The main reason for that is we've still been kind of trying to figure out what we should be prioritizing here and what our pattern should be, or like how should we be doing things. And I'll talk a little bit about that. Messages isn't as quite as useful. The voice in terms of minutes also isn't quite as useful. But generally, presence is the big one that kind of can describe records. So we see like a peak every 7 or so days, and it's basically the day that we meet every week. it's not that much more than is regularly available because people do come in and out. But so there are stats available that we're kind of tracking, and I think that's cool. I think basically every entrepreneur that I've ever talked to has said the thing that they were most interested about, or the thing that they would have done differently is kind of making sure that they were keeping metrics about the early days. And so we do have metrics, and so it's just going to be exciting to kind of see how it things over time. Um, but yeah, our biggest days is kind of hovering around 18, 17, 16 or so people. At a certain point, we made it a goal to try and get 40 people here. Although I think that is a good goal at some point. I think we shifted a priority trying to figure out how to make this sustainable. So about mid-May, it kind of became a little bit just a lot to get lectures every week. And so that's kind of why we switched over to discussion-based content. It's just a lot easier to generate. You don't have to prepare anything. And then the lecture-based is kind of accurate. Right? So if anyone wants to propose anything, we still encourage it, but we're not prioritizing it. Because if you are prioritizing it, it just takes a lot more time. It just takes a lot more energy to kind of do it, and it's not as sustainable. Okay, so if anyone has any questions about the stats, now would be kind of a good time to ask.
Hey, man, I'm sorry. How do I access the stats?
You'll where is the URL? I don't know if you have access to it.
Oh, I thought you had to click on the bot.
Yeah,
Sorry. No, it's okay.
Let's start that URL. Just put it out the URL.
Oh, thanks.
Okay.
Nice.
Okay. Harmon's gonna be. Oh, Harmon's listening. But he messaged me that a car issues with the.
Hey, Harmon. Yeah.
Join tonight. Early, he'll or if he's not available, we'll kind of jump to the discussion and then come back to him at the end. And the worst case scenario, we'll push it to another week. You there, Harmon?
Hey guys.
Hey, Herman.
And one of the things I also want to touch on is settings. There are settings for that people may find useful. In Discord, I've certainly found it useful, especially if it annoys you when people hop in and out of the channel. I'm trying to see if let's see.
I think Evan is here.
So, in the voice and video settings, oh no, in notifications, right? So a bunch of these settings can be a little bit disruptive. When people are muting mics, you'll hear a thing. When people leave or join channels, that can be a little bit frustrating. All of these are individual settings, so I can't control it for everyone. So if you do find it annoying, then if you're assigning people join and leave, this is kind of where you would change that. So we want to bring that up. And the last thing is that we've kind of been reaching out to start crowdsourcing some topics, and that's how we're kind of going to be driving out a lot of the discussions that we're having. And so thank you to everyone who's kind of gone through it and answered those topics. If we kind of going to go through kind of the next topic for next week, it's a good way to kind of go forward. And so first, thank you for answering those of you who have. And second, if you haven't, if Tom's messaging asking for the topics to talk about, then please do that, because that's going to be a great way not only to directly generate things to talk about, but also to make sure we're staying relevant for everyone. And so this is useful across the board. Okay, I'll pause there for a second that has any questions or comments if they'd like to
I just wanted to check, like, generally, um, guys, are looking for like back from us on this sugar, or not the sugar, but are you guys looking for like input from us on this like business venture that has been a bunch of people to join on these discussions and it's basically making it as useful as possible? Um, is that the main goal?
I first in terms of feedback, yeah, always welcome. And if it's blunt, if it's like if you want to say it now, we're more than welcome to it. If you want to ask me privately, also welcome to it. And yeah, at the end of the day, what we want to do is create a space where you want to invite other people. Where you're like, oh, this is super helpful for my career. I'm going to invite other software developers that are also learning. So yeah,
Nice.
please.
And of course, uh, so what if we are in the era of this technology and everyone needs to have some sort of a coding experience in order to survive within the next 50 years, maybe less. Otherwise, they're just wiped out, like their job won't be doable in kind of a manual way. Uh, so maybe having these sessions, my feedback is could be sometimes like I can invite some people that I know or like an entry level, and then there's some others who are looking for specific projects like project discussions or something like that. You know, people from um, Harvard ones that are doing business with, and some others. Um, who just sometimes have like a bunch of ideas that they want to see if it's feasible or no, and then I think this would create a lot of momentum within this uh, uh, like community that you guys are trying to build. But then other side is I think which is what everyone focuses on, which is like the interviews part. It's like the big guys that have and such like can you guys walk me through the preparation kind of like a training session if that, or something of that sort. So we can just like have these different categories that we're working on, or two to begin with, or one is already defined, which is a regular general discussion, which is what we're doing now. Then maybe split the groups and see different focuses, and then each one will create a different stream. So I know people who are entry, and you know people who are other software engineers who are might be of an advanced level. Some or someone else might know other like people who have business ideas or have some funds that they want to invest in. They just don't know how feasible is that. Like Alpaca, for example, when it started, people came up talking about it. It's a training. Um, to know like if the stock is working, like how do you work with that? Is the coding part easier or just better to do it manual? And so on and so forth. So like marrying different um, different ideas together. I hope I'm
Yeah, I'll touch on a few of the things you mentioned. I think they're all important. One is like the junior or senior, like what level is this catering to? And so it's actually like a very hard thing to sort of address. Um, Part of it is I've been working on my own version of a junior curriculum, what I'm calling a 0 to 100 programming. And I made decent progress on it, but I don't think it's quite ready to present quite yet. And so actually one of the reasons why I've stopped presenting the last couple of weeks is because my time, taking time to present is taking time away from me developing that curriculum. And so there is kind of like a junior curriculum in the works on my so that's definitely a possibility. In terms of where we're catering, we're trying to cater across the board, and then as this sort of meetup starts to grow and grow bigger, we're going to slowly start to fragment as is fit, right? So maybe that fragmentation is going to be based on levels, or maybe it's going to be based on interest. We don't really know. We're sort of in this, let's try out a bunch of different approaches, and hopefully given the right feedback, we'll sort of settle on the right approach there. In terms of like bringing in business people for one-off meetings to talk about viability optics, I think that's like a very good discussion base, right? So if we had a meeting that's like, hey, everyone bring in, or everyone wants to propose or pitch an idea, and they can get feedback on it. I think that's a great discussion, and so I think that's definitely something that if you propose to Tom, or if you add it to the kind of discussions that we can think about, that's definitely something to consider. Like I missed a few things because you touched on a few things, but is there anything else that you want me to touch on, Mustafa?
Oh no, that's decent. And however I can help, yeah,
Awesome,
that's about
thank
it.
you. Yeah. Yeah, I mean, honestly, the big thing is kind of asking questions and conversations, and then as things start to go well, making sure that you share kind of the links with other people so that other people see what this community starts to grow. We have talked about doing like a big push over the month. One of the reasons I started today's lesson with the stats is to kind of show that we can really live up to that, and that's just the reality of it. The reason we didn't is because we were still kind of enabling how things work. And it's not an excuse, it's just the reason we chose things to be that way. But yeah, over time we're trying to grow this a bigger community where it's a little bit more fragmented, but it's also somewhat frequency.
Great. We'll have some points later. Just maybe you can have further like one-on-one discussion or something. Just like write down a bunch of ideas or questions, and maybe hopefully I could be someone.
If whatever feels like they're asking like a question that might be off topic or anything, if you put a text out, you can kind of determine if it's relevant for the conversation. Okay. Yeah, this seems like a good take on the administrative side of things. So now we'll go into the leak coding thing. Edwin, are you there?
Yep. Yeah. Hope
Do you
everybody.
mind taking it over?
Yeah. Hope everybody's safe and healthy. I will share this. All right. So let me know if you can't see the screen. Otherwise, we will continue. So hopefully you've taken a look at this problem. But if not, let me briefly go over it. So a very simple problem in terms of the scope. It's given a binary tree, return all the root to leaf paths. So this is a binary tree. The root is node with value 1, and it has 2 baby children nodes, and each have values 2 and 3. And then node 2 has another child node, which has a value of 5. So we can see that all the root to leaf paths, and the leaf is defined as a node with no children, is 5 and 3. Remember, 2 is not a leaf because it does have 1 child. So all the root to leaf paths, all the legal paths are 1 to 5 and 1 to 3. So how do we do this programmatically in terms of finding all the possible binary tree paths that go from roots all the way to a leaf? And there's 2 classic ways of doing this, and it's breadth first search and depth first search. Now, you've seen my problems from the past few weeks. I've done a lot of depth first search solutions because a lot of problems lend themselves to this algorithmic traversal of a tree. And it also, of course, lends itself to a graph because a tree itself is just a subset of a graph. You can see that you can call this a graph if you want, but you can see that this tree is just a very simple form of a graph. So let's get started. So I'm going to do both of the solutions, but this will actually take a lot quicker than you might imagine because a breadth first search and a depth first search are very similar to each other. They're both traversing the entire tree, but they only differ in terms of the container they use in terms of traversing. So a breadth first search does it in terms of exactly as it says. It does it by looking at breadth. So in terms of traversing this tree, it's going to start with the root, node 1, then it's going to go to 2 and 3, and then it's going to go to 5. In terms of a depth first search, it's going to go deep in terms of one path before it explores other paths. So depth first search is going to go through 1, 2, 5, and then go to 1, 3. So the way this is accomplished programmatically is that a breadth first search uses what is known as a queue data structure. So let's write it out. So I'm going to write out a function. We're just going to pass out roots. And the reason why I want to write out a function instead of just doing breadth first search is because we're going to write out a function for breadth first search as well. So we're going to write out breadth first search, and then it's going to have the roots. And now here comes the fun part. This is, of course, we have to have all the paths. Let's just call this. So lead code expects the outputs to be a list of strings. So we're going to initialize that initial output in terms of this variable paths of being a list, and then we're going to push in the possible paths as strings into this list, and we're going to return paths as our answer. And now we have all this white space to actually write the algorithm. So a queue is uses first in, first out in terms of ordering. The classic way it's done in Python is use the queue structure, but I can actually for the sake of simplicity, I'll just make this a list, and it's going to be a list of roots and a possible path. In which case, we're just going to start with an empty string. So we can actually mimic a queue data structure by just using a list or an array. But we have to remember we can't, in terms of pulling stuff out of this queue, we can't pull it from the end of the list. We have to pull it at the beginning of the list. Or if you decide to do that, you have to make sure that whenever you're pulling stuff from this list, that you're appending it in the opposite direction, at the other end of the queue. Otherwise, it wouldn't be a queue, it would be a stack. Because if you're appending and pulling stuff from, or popping stuff from this queue at the same time in the same end, let's say like you're doing it at the very last element, then that would be a stack, and it would not be, even though it's using the same list data structure, it would not be considered a queue first in, first out movement. So now, while this queue exists, so what we've done now is I've initialized the first node in the queue, which is just our roots, and our root is going to be, this test case is going to be a list of 1, 2, 3, null, 5, and this is just representation of this binary tree into list form. So you can see that 1 is our first root, there shouldn't be any controversy over that, and then you can see 2 and 3 are both children of this initial node. So it's a little bit confusing in the sense that 2 and 3 are in this order, but this is how we represent trees into a list. And you can see a null and a 5. This null and 5 are actually children of not the prior index node, but the one before that. So you can see that 2 and 3 are both children of the first. And you can see that null and 5 are children of 2. And if we had additional nodes in this tree, the 2 additional nodes would be children of 3, and so on and so forth. And the 2 additional nodes after that would be children of this node at position 0, 1, 2, 3, in position 3. So that's how we represent a tree in list form. So we're initializing our queue with the first node, which is the root, and a possible path, which is currently empty right now. So now let's implement a breadth first search. So we have to, this queue is meaningless by itself. What's really important is that we actually pull stuff out of this queue. So we're going to do queue.pop. I'm just going to pop the first element because I'm going to append elements to the very end. So it's going to follow that first in, first out movement. And if this node, which is currently our root node, does not have a left node, and it does not have a right node, it means that we have a solution. So we're going to append to our output list of paths a solution of, I'm going to use the F statement way of formatting a path, and we want the node value, and that would be the end of it in terms of this possible solution. However, if we haven't hit the end, we have to keep traversing, and we check to see if the current node that we're on, right now we're just in the root phase. Let's see if this node has a write, and if it does have a write, we need to append additional things to this queue. So we're going to append another tuple with node.left, and here comes the fun part. We're increasing the length of our list. Well, not the length of the list, but we're adding a path to our string path, and this string path will represent a total legal path in its own right. So, for example, we're going to be adding a 1, 2, 5 path, and then this path will be slowly increased in terms of its length, but it is a string. So let me write this out, and LeetCode expects us to have this little arrow sign in terms of what the string is, so we're going to write that. And now we made this tuple. So let's copy this. Right, so let's copy that, and then by symmetry, let's explore the left node. It's more intuitive. We can move this left node to the. We can first explore it. We can check the left node, and then because we read from left to right, probably a little bit more intuitive. We first check the left node, and then. Right, and then yeah, by symmetry, we're going to check the left node, and we're going to append this node. If there is a node that exists, and we can see that we start the root node, and we're going to, we see that it does not have no children. So we'll repeat again, it has children, so we're going to skip over this initial if statement. We see that it has a left child, so we're going to append that left child node into the queue, and then we're going to increase our path from 1 to 2. So, and we're going to keep doing this until we've also done 1 to 3. And we can see that 3 that has no children, so that will be a legal path, 1 to 3, and then the node remaining in the queue will be 2 to 5, and we can see that 2 to 5 is valid, and it's going to finish that path of 1, 2, 5. So the easiest way to visualize this is let me print out the queue, and let me print out path. Here. All right, so let's check out the outputs. Oh, sorry. Yeah, this is just BFS. And you can see in a depth first search, I just want to make sure we really get the breadth first search, because depth first search is literally just substituting this queue, and all this code is going to be almost exactly the same as a breadth first search. So in this BFS, you can see that we start with a queue of 1, 2, 5, and you can see the root node. It's kind of not very intuitive to get used to it in terms of, but this is actually just the root node, and you can see its pointers to its references to its children nodes, and you can see the references that its children nodes has to its own children, and you can see that is our queue initially just has the root node, and with all its references, of course, to its children, so that's why we're able to traverse it by doing if node.left and if node.right. And you can see that we first append the 1 to 3 node path, and then we append the 1, 2, 5 path. And this should make sense because remember, in the breadth first search, we're first doing 1, 2, 3, then 5. So of course the 3 terminates earlier than us going to the next level of the tree and then finding the 125 path. So that's what breadth first search is, and you can see just in the manner of like the order in which the paths are appended that that's the case. And you can step through this in terms of exactly how it works, but that's in essence how it works. First, we start with the root node, we pop it out, so the queue now has no elements. We find out there's a left node, so we push it back into queue. So now the queue has node 2 with its reference to its child node of 5, but you can see the path beginning to take form because now we have the 1 to arrow here. And then the queue, because we also did if node.right, also has the node 3 here, and also the beginnings of the path here, 1 path here. And then you can see, of course, we pop out the first element, the first node, and now our queue just has the remaining node of 3 from initially before here. And we did the if node.left on the pop out node, which was the node of 2, and you can see that it does have indeed a node.right. So we push that, we append that at the end of the queue of the node 5. And you can see that when we pop out this queue of node 3, we see that it has no children, so it's going to append to our output paths answer, and that will be the initial path of 1 to 3. And then you can see that our remaining node in the queue is node 5, and you can see that it's, as expected, the path begins 1 to 2. And then once we pop it out of the queue has no more elements. The path is 1 to 2. We can see that the node that we're currently doing, the last node is node 5. Node 5 has no children, so we append it and complete the path of 1 to 2, and we complete the 5 here. So that's breadth first search. In terms of depth first search, which is my favorite, I'm going to do it iteratively. You've seen me done it recursively like a million times at this point. And I always like a recursive solution, but the recursive solution is just like a little bit, it's almost exactly the same as iterative, but there's like a mental leap that you have to make. Whereas if you do it iteratively here, it's just, you can see the classic symmetry it has with breadth first search. So it's actually, we're just going to call it a stack. But remember, it's still using a list status structure in Python, so we don't have to change that. And then we just have to rename all this fun stuff. Let's turn out the stack, and instead of popping it at the initial element, this is literally the only change I'm making besides renaming queue. I'm just going to pop it at the very last, because the stack is last in, first out, and I'm going to still append it to the very end. I'm just renaming queue here, and you can see, and then of course, let's, instead of doing breadth first search, let's do the depth first search function we defined here. And if all goes according to plan, some implementation. All right, let's see if this works. All right, yep, still goes according to plan. You can see in terms of the stack, the depth first search does nearly the same as the breadth first search. And in terms of walking through it, you can see that initially, so let me print out this. Oh, so you can see that right now it's still a list, but I'm now, instead of calling it a queue, I'm going to refer to it as a stack, because now we're popping and appending it to the very end instead of popping it at the beginning and appending at the end. So it's the last thing first out right now. And you can see we start with the root node in the stack. It's the node of 1 and all its references to all its babies. And then we pop it out of the stack, and now we have node 2 with its reference to node 5 and node 3 with no children. You can see initial path being built here. And then we pop it out node 2, and we can see that node 2 has no left child, but it has a right child of node 5. And you can see the initial build here of 1. And then we pop it out in terms of, oh wait, sorry. So we're popping out at the very end. So you can see that our node 2 to 5 is still in the stack, because now we're popping out node 3, and you can see that node 3 is gone, and it will build out the initial path of 1 to 3 because we've already taken care of node 3. And then you can see, then we return back to node 2 and 5, which has been patiently waiting on the stack, and now we are able to pop out node 2, and then node 2 has the right reference to node 5, and then we pop out node 5, and then we complete the path from 1 to 5. And let's submit the depth first search. None-type object has no attribute left. Not node left and not node right. I think what we should do is check to make sure that we actually have a root. It's not node left. So let's do it here. If not, yep, and that's the solution.
Very good.
That's just a guard clause. A guard is different. But if there's no other questions, that's it for me.
I just want to make a comment because I think this example is such a good example, especially how you presented it, of the difference between breadth first search and depth first search, and especially how you explicitly change the name of the variables, which is like one I think is very interesting because a lot of people wouldn't, and I think it's very important to talk about how naming variables matters when you're reading code. Like when you're writing code, it's actually super easy to not care about variable names, but when you're actually reading code, it becomes very relevant. But also, one line of code that subtly changed in this algorithm, now all of a sudden you're not doing a drastically different solution, but it's still enough of a difference to talk about. And if this was like a pathfinding algorithm, it would all of a sudden lead to drastically different performance. So I think like this is, these last 10-15 minutes is actually 10-15 minutes that I'd point to people to actually like spend time to think about understanding BFS and DFS. I do think they're very fundamental concepts, and I think you've highlighted those differences very well. So I want to congratulate you. Thank you for that.
Yep. No, thank you. Yeah. Let me know if you guys have any other questions. But signing off.
Edwin?
Yes, Sunmin.
Hey, Sumnin.
Thank you for the explanation. I was actually going to ask the exact same question that the mentor said. Like I was wondering what was the theoretical difference between BFS and the DFS. So I see the code. There is only one line that you just wrote it over there. What's the main difference between them? Sorry, I have no background knowledge, so my question might be silly.
Yeah, it's really. It's the order in which it does things in terms of traversal, right? So it traverses the nodes in a different order. So in a depth first search, it's going to go through deeply into one possible path before returning back to the original node. So that's why it's called depth first search, right? So it's going to do like a deep dive in terms of like 1, 2, and 5, and then do 1, 2, 3 instead of depth first search, which patiently does 1, 2, 3, then 5. Does that make sense?
Yeah, imagine if like you're like in a tunnel system, and breadth first search could be like going down the tunnel, or depth first could be jumping down a tunnel. Yeah, so you're basically like exploring in breadth first search. You're exploring each level of the tree, like each horizontal level. Whereas with depth first search, you're going completely vertical, down one particular path. I just got weekly free internet. Is there some more efficient solution to this that we're missing? Because I noticed when you submitted it, it ranked it as a slow solution, but I'm not really seeing improvements
Yeah, yeah. Like LeetCode is very yeah. It just may be like slow internet or something, or like just a slow judge because I find it to be very intermittent. So like if I submit it again, it could possibly be a lot faster. But actually, it seems like it's pretty stuck here. Let me try it one more time. But yeah, like a lot of it is very precious. Now it's like 5.8. So it's like in terms of like possible ways of optimizing this. Like for example, we haven't. I've been doing depth first search like this way, but and I haven't submitted depth first search. So it's like submit depth first search. But for example, instead of using this like queue that I just constructed off the list, the classic way in LeetCode Python would be to use the collections.the and that has like its own micro optimization. So I think that would help boost the speed. And there may be ways of caching the path that you have instead of like implementing this initial string all the time. I think it's probably some form of caching that you can do possibly because if you convert this iterative to like a recursive solution, and then I can see you can add an additional variable in terms of like a cache, and then you could pull from that cache of the initial paths that have already been built out instead of like building out the path again.
I think the string, the F string part, I think concatenation of two strings is actually somewhat of an expensive operation relatively. And so what I think might help is doing that all the way after you've built out all of your possible paths first. Yeah, do you have like an array that you're appending to, and then all the way at the end? And then I'm sure if you're now talking returning an arrays, now there's the what if you do some sort of list comprehension on that? But I don't have any field.
Yeah. I think the F statement is, even though it looks very elegant, maybe even doing the pluses is probably a little bit more efficient. But like, let's say like I have some kind of string path here, and then I'm like appending it to this initial string path and trying to construct two additional strings. I think that could also be a little bit more efficient. Just using one variable instead of two. But yeah, this is fairly slow, but it's right.
Yeah. I was just I immediately see some I guess the strings might be taking that sort of time right
Yeah, I really think that, but yeah, it's probably the F statement and the string. Yeah, because even like the recursive, like to be honest, I think this iterative solution is probably faster than the recursive.
Especially
yeah. So it is probably the F statement. Yeah, probably most of these Python solutions, most of these people don't use F statement.
Yeah.
Yeah, it's true.
This is a good example. Exactly. So I think this is a good example where like a lot of people optimize for performance in code, and I think the best solution in this is going to be maybe like 10-20% faster. Whereas the readability really goes downhill very quickly, and I think you've caught on probably the most readable solution. And I think a lot of optimization around performance is useless compared to optimization around readability.
Yeah. It is surprising though, like yeah, until you brought it up, Andre, like I did not. I do think it's the F statements, and I did not realize they were this slow.
Yeah, me neither. That's why I was just
Yeah.
yeah, but to cover up on that I just said, I mean this these functions that was addressed. I never expected these functions in a code base if you find them in a code base for whatever reason implemented them from scratch. I expect them to be less readable because this is really where you want the firms to be ready for rapid purchases. If you have a higher level function, I would make the other trade-off. But for these, yeah, I would definitely sacrifice.
Yeah. Yeah, that's it. If there were no other questions, time for pizza.
And a Coca-Cola.
Yeah. And a Diet Coke. Yeah.
That's our sponsor.
Yeah, we're gonna start throwing out.
Where's my pizza, man?
Merchandise.
What's your address in text? I tease. This is down. All right, anyone, thank you. Eric. Honestly, this one like got me very excited because I've been talking about it for a while with getting Edwin's things, all of Edwin's recoded ones, and making a YouTube playlist out of this. And this one just got me so excited that we're gonna make it a priority to make that playlist sometime over the next 2 weeks. I think this was really great. So thank you, Edwin. Okay, next up, if Harmon, are you there?
Yep.
You ready to present?
Yeah, I'm looking forward to that one, Armin.
Awesome.
Nice.
All right. You want me to introduce you? Or do you want to introduce yourself?
Either way, it's fine.
Right. Harmon is a DevOps wizard who's helped out numerous people in my life with various cloud-based problems. Currently, he's working for you're at a hedge fund, right?
Yeah.
Reorg,
Basically, yeah, it's like a restructuring organization, bankruptcy, debt analysis. We track all of those, and this is like a pretty good time for us because a lot of companies are going bankrupt. So much work for us. We are getting tons of data, which crashed our Elasticsearch cluster today, and I had just been like working on that production issue. I just got off the call like 15-20 minutes back. So yeah, so okay, that was like a simple intro. Apart from that, I have experience working with a lot of DevOps tools and technologies. I work on the backend stuff from time to time. I write stuff mostly in Python, and recently, like I've started using like Node and Vue.js because my company uses it. So I've been writing some stuff over there as well. A lot of stuff with AWS, cloud computing, Google Cloud. Doing a lot of like stuff with like Linux, Ubuntu servers and systems. A lot of like stuff with database, a lot of different database technology, SQL, Postgres, Couchbase, Redis, Mongo, all of those things I have worked with. And my recent like last year experiences, I have been building the whole security infrastructure from scratch at Real. So that's what I've been doing from past 1 year. Today I wanna talk about a bit about like recently we had a lecture about Docker and Kubernetes. I wanna talk about Docker Compose. Most of the people here who would have worked with Docker might have used Docker Compose for their dev environments, staging production, or they might have come across Docker Compose files and all of this. So yeah, if you haven't used Docker, this is going to be like an introduction, very basic. Uh, this is going to be useful because like going forward, I'm going to do like few talks about setting up like your application to Docker, how to deploy them, how to like monitor them, all of those things. So this is like a basic like introduction lecture, running all those containers through Docker Compose. Okay,
Hey, Herman,
let me share my screen. Sure.
just before we move forward, a quick question: is there any prerequisite to fully grasp your introduction to your lecture?
So like if you have worked with any Docker environments, or have you worked with Docker before?
Mm-hmm. Oh, okay. That's it, right? Yeah, obviously,
Okay.
Python.
So if you haven't worked with any of that, we would be like I give a like basic overview of how different how we write the whole code and how we create images
Mhm.
and how we use compose file.
Oh, perfect.
So basically so you have your like basic code how you want to like talk between like multiple different things. So I'll just give a overview of how we do that.
Okay. Thank you.
Uh, does that answer your question?
Oh yeah, absolutely. Thank you. Thank you for clarifying.
Great. So I'm gonna share my screen.
Perfect.
Let me know if you don't see it. Okay. So Blimp by Kelda. So how I came across this tool? These guys are still in beta version. A couple of years back, the CEO of this company, who is like a PhD in software-defined networking from Stanford, he reached out to me to talk about what are the pain points of using Docker in local environment. So I have been working with this guy on and off, like just like a product person or like a beta tester or whatever you want to call it. I've been like telling him, okay, like these are the key points, these are the things I'm facing locally. I want to write the stuff I'm facing when I run Docker containers on things, and then they went to build out this product. Uh, I'm sure that he might have reached out to hundreds of other people as well, but I'm just one of them. Okay. So first, I wanna talk about what is Docker Compose. Uh, so before that, for people who don't know what is what is a Docker container, uh, let me show you. Okay, so can you guys see my screen?
Yep.
Yes. Okay. So this is basically one simple application, which a one node application which sits on my server, right? You could see all the different files. This is the app file, the config, like the package.json, which is compiled, some public files, server.js, configs, and all of those things. The config has my database set up and all of those things. So I have this file. I have this application. This is one file. It is pretty easy. I want to serve this file. I can just run it locally. I can serve it to like local host, have it running on my local host, and then I can keep using it. But what if I have another application and I want to talk, like make it talk to this? Okay, two applications, it's still fine. I can make it work. What about you have 20 applications and you want all of them to talk to each other? It becomes pretty difficult to like manage each of those applications. On the other note, you have like your 20 application. You need some sort of like orchestration tool to manage it, or like you need something where you can manage or keep a log of which application is running, which is not running, and all of those different things. Uh, Along with that, you want so all these 20 applications, if they are running on your like laptop, or if they are running on your server, or if they are running on your any virtual machine, they are going to be fighting for the underlying resource. So, like for instance, my application one, if I haven't defined anything, it's gonna take up all my CPU and memory, and then leave nothing else for my other 19 applications. So, how do you like control all of these things? You could control it through the code as well, but that's like what if you like change machines and you deploy the code on a different machine? You are locally using it, it's fine. You go from another machine to a different machine, to machine A, B, C. It becomes pretty difficult to do it through the code. So that's where like Docker containers come in. Like you could create the whole image of this your application, which you do it through your Docker file. Uh, I'm gonna show you how a Docker file looks like. So this is like a basic Docker file, which what it's doing is that we have a lot of like predefined images on Docker Hub. We are pulling that predefined image, which just pulls that image. What it's going to do is it's going to create a sandbox environment on your laptop, and it would have like node version installed. For instance, like you spin up a VM and you say, okay, I want this VM to be one, or I'm spinning up this VM, I want it to have like Windows. So the same way, what we are doing is we are spinning up a VM or like a sandbox, or what we call as container, and we wanted the base edge, or it we wanted to have like the node already installed. Second thing which we want is that we are exposing our port 80 ADI. So for instance, like we open up connections of so that our application can be served. For servers, we there are like a ton of different things. We use IP tables, we use security groups on AWS so that our traffic can flow in and out of it. On Docker containers, we expose the ports to Docker. So then I have defined the working directory. So working directory is basically when I log into my container, it would basically take me to this. If, for instance, if you log into our servers, it takes you to your home directory. If I log into like a new shell, like in a terminal, if you could see like pretty slow. So it took me to my laptop's home directory. Same way for this Docker file. When I log in or check into my container, it's going to take me to this like path location. For the copy command, what I'm doing is basically whatever is in this dot means that whatever is in my local directory, like all these files, I want to copy it to this path location. Uh, that's that, nothing much. Then I'm just running the basic command of npm install, and then run npm install one more time. So yeah, so that's what it's gonna do is like it's gonna build all the files which I have defined, and then build like compile the whole it's gonna create like a new modules folder and all of those things which I require like all the libraries for it. So that's just like a basic Docker file. Uh, so that's how you basically want to spin up one container. What if you like, for instance, like you have 20 applications? You're not going to go to like each you have created this one Docker file. So the same way you're gonna have like 19 other different Docker files for your 20 applications. So there's a way where you can like go into each you can go and build the image, and then like what you can do is through the Docker command, you could basically like say, okay, I want to run application 1, application 2, application 3. You could do it manually. But if you want all of those applications to run at once, what you could do is you could use Docker Compose. So um, that's how a Docker Compose file looks like. It has like a YAML format where we define our whole like the services which we want to build. Like it could be like your like web server, maybe like say Nginx, Apache, whatever it is, or like your whole web application, which is this in this space. You want to build your database and all of those things. So I'm gonna come back and explain all this. First, I'm gonna go over what is Docker Compose now. So Compose is basically a tool for defining and running multiple container Docker applications. Like I explained, like if you have 20 applications, you don't want to just like spin up like each uh, Docker container to running one Docker file. With Compose, you use a YAML file to configure your application services. Then with just a single command, you create and start all those services from your configuration. You could think of it like a script where you are running all your different services which you have. Like if you wanna like instead of like writing a script, you have like a Docker Compose file. Uh, then the another good thing for Docker Compose is it works in all environments. Like you could use it in production, staging, development, testing, and as well as for your continuous integration workflows. For instance, I could use it basically to like use it for my development work. If I'm fine with if I'm just running a few applications, my teammates are fine with it. My company doesn't care about whatever like the best practices is. I could even use it to do or run it in production. Okay, so what is Flink? Uh, Before that, like I'm gonna show you like guys come back over here and explain you what Docker Compose file does for us. So we have, or in this Docker Compose file, I have basically defined two containers. My one container is serving my web application, which is which has all these files, for which I showed you the Docker file as well. And the other Docker container is just creating a Mongo database, and it is being served on port 27,070, which is like the default port for Mongo. Okay, so for coming to the first line, we just defined different versions. Like Docker Compose files had different versions before. It had like where it started from version 1 to, and now we have reached version 3. For defining our different applications and different containers, we define it under services, and under services we give it a name of what name we want to give that particular thing for the name for our application. From there, we are defining it what image we want it. So when we use a Docker file, we basically package our whole, like package uh, all of these files, our whole microservice or our whole simple application, and we just create an image of it. That image we can store we have like a lot of like cloud repositories, like something like Docker Hub. We have AWS has its own repository, Google Cloud has its own repository. So what we could do is we can define and build that like this whole application, create an image of it. It's equivalent to like creating a snapshot of your server, or like taking like a picture of anything and then storing it the same way you want it, so that you can just pull that picture out and then you have all of those things uh, the very same way. So that's what it's basically going to do. So you define the name of the image, and then you define the version of that image. Like you could have multiple versions. For instance, at present, I give it like the image name and the version as like version one. You made some code changes, you compile it again, and now you want to call it version two. So you can like deploy that version two into your cloud repository, you push it to your cloud repository, and from there, now you have two different images with different versions. So what you could do is like you could basically run those different versions and compare them at the same time. If you were running on servers, what you would have to do is like you would have to like roll back all those changes, take out those changes, or maybe switch between branches, or maybe like delete the code, all of those things. So that's where like Docker containers and images becomes very easy to work with. Then like it's just we define the entry point. So entry point is like what I'm doing is I just want it to run this basic shell command, basic entry point like install the application and just serve my server.js file. Working directory is the same as what I have defined in my Docker file and the ports I wanna run my application on. Yeah, the thing is like I'm defining like what it depends on. So it depends on my Mongo container. So if my Mongo container is not there, this application or the Docker Compose file is just gonna give me errors saying that okay, your Mongo, we cannot find your Mongo container. You have it like defined, like you have defined it, but we cannot find it, so we cannot bring up this web application. It's just basically like creating like a check at your end that you have a database for your web application. Um, I'm defining all these volumes. So volumes basically you can like attach to your containers, where what you do is like whatever you wanna like change over here. Like if you wanna have like a log file, you create a log file. That log file or whatever you create over here is also gonna be copied over to your Docker container, or it could be any other file. You're just treating it as in like a external volume, which is like always attached to the container. Uh, then coming on to like the Mongo database cluster, like we have like a predefined Mongo image. We are not making any changes to the default configurations. We are just going to use it like that, and we are just showing it on port 27017. Okay, are there any questions till now? Like this is basically an overview of like Docker Compose, how we write Docker files, what Docker containers are, and all of those things.
Harm, I have a question. Actually, two. One is you have like the source directory as user slash source slash app. I've seen that convention a lot, but I've never really found an explanation of why that is. I was wondering if you had that.
This one?
Yeah, so, well, the working directory is
Okay.
what I've always seen it, but
It's like you could define anything. Like it doesn't matter. You could just do like root. That's it. Like it doesn't matter that much. It's basically whatever you want to define it. People use it everywhere just for like following best practices, or they just wanna like have like a basic method of following like a format or YAML file and all of this. You could define anything.
okay. So it's more convention than anything. I'm worried about like namespacing issues, like if you're overwriting another file, or if you're building on top of another Docker image that uses the root directory for something. And that was what I thought might be the case, but yeah.
No, not really. Like unless you like have like different volumes, like whatever you're defining over here, you define in your volumes as well. It shouldn't like override or interfere with other Docker containers or anything like that.
Okay. And the other thing, I once was trying to use Docker Compose to orchestrate like a testing suite where essentially you have a Mongo thing, and then you had another like one of my apps was a seed server, right? So, or a seed
Okay.
database. One of the things I found though was that Docker Compose doesn't guarantee that your service is 100% up and running. Like it guarantees that it started, it doesn't guarantee that it's already accepting calls. So I eventually stopped going down that route. But I was wondering if you can comment on like the using a instead of having you have two services there, right? You have a web service and a Mongo service. But what if you had like a seed Mongo service? Is that a good idea? At one point I thought it might be, but now I'm at the point where I think it's probably not. And I was wondering if you had a take on it.
The seed Mongo.
Yeah, like a seed Mongo service where all it is essentially a script that seeds the Mongo database, and then the web service, instead of depending on the Mongo database, it would depend on the seed server service. The
So
seed
like you're
database
saying,
service.
if your seed Mongo service is not running, then the web application shouldn't be served, right?
Well, yeah. So essentially, I wanted like this kind of cascade where the first thing up is Mongo, and then Mongo gets seeded by another service, and then the actual app that I'm working on works against the Mongo database.
Okay. So
That's
what in that case you have to do is like you see this depends on. So one of these things like has to be like your Mongo's basic container, or if you're any config changes or something like that. And then there has to be like another like you define basically in that in this particular file where you just go and say okay there's another service like something something like I would say like your seed script and everything. And then over here, you at the top, you have to come and like create another thing like a seed script source. And then you create like another Docker file, like you define the image for what that particular seed service is doing for you, blah blah blah, and all of those stuff. So
Do you
that's
think
what you
this
have.
is a good pattern?
I would follow this if I had to do something like this because either way, like you first have to see your Mongo and then you want your web to come up, right? So for seeding your Mongo, you have to define it with some data or whatever you are doing to it, right? If you take like a basic Mongo cluster, what you could have is over here only you could like how you have ports and everything. The other way could be you find the entry point over here, and in that entry point, from the base directory, you could then run your like Python seed script or like anything like or like maybe like another stuff. But for that one, like you basically have to create your all of your schemas and everything and all of those things, which you would be like I guess would be doing like either way, right?
Yeah. And is there any risk of reseeding the same data if you're doing this? Because I see you have a volume, and the way I think volume works is that's how you persist memory from different like runs of Docker.
Yeah.
And
Yes.
so
So what it's gonna do is like it's gonna store. So if you like, so for instance, you close or shut off your container, your volume is still gonna be there in this case. So for instance, you scratch your container, you build like a new version of Mongo, you wanna do new stuff, your old data is still gonna be stored on the volume. It's not gonna go away unless you just scratch the volume yourself and then we
okay. Okay. Thank you.
answer your question.
Yeah. Okay.
Cool.
Hey, Herman.
Does anyone have any questions?
Yes, I actually I do. Just like junior people here, just they didn't understand what image, virtual machine, sandbox, and container. I mean, container not, but those three. What are they? Just can you quickly explain to them what they are?
Sure. So basically, let me explain to you guys what would be like my sandbox environment or like my like a virtual environment, or how, like, what's the difference between those things, and like what the servers are and what virtual machines are and all of that. So let me first give an overview of, I don't uh, let me show you one of the things uh, which I have built. Uh,
Hey, Day, hear me?
okay, so this is basically, I'm just, hey, can you hear me?
Now I can. Yeah, you were gone for like good 2 3 seconds.
Oh, okay. So yeah, so like I was saying, like basic overview of like a virtual environment or a sandbox environment would be something like for instance, right now I'm working on my local machine, right? So everything which I'm doing is on my own directory. Uh, like uh, like for instance, if I make any changes to this particular file, if I make changes to this Docker file, then for instance, like if I take out like this particular line, let's take out line number two. Okay, so
I'm sorry, Herman.
like
I kind of
let's
I
take out this
lost
line.
your.
Okay,
Uh,
can you hear me?
no, I can hear you, but I can see your screen actually. Were you coding something?
Yeah, I was just like giving an example of like Docker environment, like virtual environments and sandbox environments.
Oh, okay. Just give me one moment. I'm
That was
sorry.
that was your question, right? Like a basic overview of like what of like virtual environments are, what are sandboxes, what are servers, and all of those things. Right?
Right.
Or did I get the question wrong?
No, no, no. You got the correct question. I'm sorry. You got the question correctly. Because
Okay.
hello.
I think I dropped you. I wasn't able to hear you.
No, I say no. Yes, you got you got my question correctly.
Okay. Okay. Okay, so yeah, so like I was explaining, so so basically like the virtual environments and sandbox environments are basically like different environments which we create on a lot of different machines. For instance, if like 10 people are working, like we have like 10 developers, and all of them are working on a single file. So if someone, if for instance, developer one makes a change to that file and it breaks the code for developer two, and for the others as well. So in that case, it loses productivity. There has to be like a lot of communication. Here, I'm making changes to this. I'm making changes to that code and all of those things. So it is like pretty difficult. It's pretty messy, and it causes from it. So that we create like a different like for each developer is gonna have their, and they can use it for like in whichever way they want. So like developer one has his own like imaginary virtual environment where he wants to write his own code. The same way is gonna be like for each of the developer.
Right.
Uh, and like and in that way, that's how like our images work. So now you have your own virtual environment, but your own virtual environment is sitting on your laptop, and you want to show it to your other developer who has its own virtual environment, but he is sitting in San Francisco.
Mm-hmm.
So you cannot show it to him. So that's where like Docker containers come. They are basically your those are your virtual environment where you package all your environment in an image and you push that image into a cloud repository which can be shared. Like it's gonna be like GitHub,
Oh,
but
okay.
for imaging.
Oh, I
So
see. I see. Yeah.
yeah, so for at GitHub, you store all your code in all these like image repositories. You just have your whole application, and you just create that image of your whole your application and just push it to that particular Docker repository. Everyone can just pull that image and then they can see the code, what code you have written on their local machine or any server or anything.
Gotcha.
Does
That's.
that
Oh
answer your
yes,
question?
absolutely. That's very clear, crystal clear. Now I do understand actually.
Great, great. Okay.
And just a quick note for the
So
senior people, like coming from a junior developer. For example,
mhm.
like I have a hard time to understand those like vocabulary. Like at first I didn't know what GraphQL was. Now image, when I hear image, I actually imagine like an image, like a like a JPEG kind of thing, you know. So like I have to train my brain to start like automatically to have that concept right away. So yes, now I do understand. Thank you
Okay,
for your explanation.
okay. So yeah, so it's like basically like for instance, like we have the JPEG image. We have that. It's not gonna change. This is basically like an image of our whole code. We have one version of it. There, that's the like a static image. It's not gonna change unless we overwrite it or something like that. So it's just basically the same concept, but with like the code. So yeah.
Right, right. I got the concept now. Thank you very much. Appreciate it.
Cool. Okay, great. Okay, so moving on to we did what is stock control. So like we have now we define all these files in Docker Compose. We define all our different containers, and now we want to run it. Uh, so like that's what we want. We want to have all these things. Like we have created our application, we have written code, we have defined everything. Now we want to run and see what our code does. So the thing, the basic command is you have Docker Compose installed on your laptop, and then you just do like Docker Compose up. What it's going to do is like it's basically pulling that image which I have put on my repository, like I do like git clone of my code. This
Mm-hmm.
is just basically cloning that whole image, and it's
That's cool.
basically build. Um, I think I'm just building it for the first time. That's why it's taking some like more time. But
That's
usually
okay.
it caches all of this over the time, and then it doesn't take that like the pull of the image doesn't take that much. Uh, Let me get my charger real quick.
Sure.
Yeah. So
Sorry.
since no.
Yeah. So this is just what it's doing is this is basically building my whole application, and you see it created my whole web application which I had defined over here, and it created my Mongo cluster. If I see over here, I defined the port 8080 in my Docker Compose spot. So my application is running on port 8080. If I go to my local host 8080, you could see I have my basically my application. Which just says okay, like my to-do list, what I have to do. I could just say okay, like anything I want to do or attend meetup, I add it and it gets stored into my Mongo cluster. Like you could see, like there was a push request to my endpoint. So that's all basically like running everything to Docker Compose. Uh, so yeah, now your whole application is running. It's perfectly fine, but over the time, your application keeps on growing. You have like right now, I just have 2 containers. Over the time, you have like 20 containers. It's taking like let me show you the monitor. Like you could see like okay, the CPU is like it's taking so much. Like right now, it's just taking 4.7% CPU for running Docker on my Hyperkit. Uh, then if I wanna see like how much other CPU and all of these things it's taking, like the RAM, you could see like we're doing like Docker stats. Each of my like simple container is taking like this much is the memory usage, for all of my like simple applications which I have just run. These are like containers for my different applications, like an Nginx web server, WordPress, like marketing side platform.
Well, that's
So
so cool.
right now I just have like 1, 2, 3, 4, 5, 6, 7 different containers which are running and they are like using all of these resources on my laptop. If I add on more services, if I add on more containers, what's going to happen? My laptop is eventually going to become slow. It is going to run out of CPU. It is going to run out of memory. And then all those issues start like, oh, hey, my laptop is very slow. I cannot run anything. I'm running containers, but they are very heavy. I cannot run into I cannot run it on my laptop because it has like certain like limit that it can just give me like 8 gigs of memory or 16 gigs of memory. It can only give me like 250 gigs of storage, and all of those things start taking in. And there's like the end of hope for all the dev environments. The developer goes to like his Linux administrator or like a DevOps person, and he say, "Hey, help me out! I cannot write code on my laptop anymore." And then the DevOps people have to start thinking of like creating like a huge server for him, create his own sandbox environment and all of it. So that's where this blimp comes in. So this is like a tool uh, which I have been like working with these guys on and off. So basically, what it's gonna do is it's gonna do the same thing what I have done over here, like running the whole Docker Compose containers. It's gonna run everything, my whole application for me, but it's not gonna run on my laptop. What it's gonna do is it's gonna run everything in their own cloud environment. So my all of my dev application is gonna be run in their sandbox environment. So and they have like a lot of resources. They have predefined it. They are running on their Kubernetes cluster and all of those things. So I'm just going to run over this. So Blink is a tool for running Docker Compose in cloud. It reduces CPU and when you use it on your laptop by running your container in the cloud instead of locally. In many cases, this can lead to a much faster and more pleasant development work. So why we want to use it? So even with just a few containers, Docker can use a lot of RAM and CPU. As the number of containers you need for development grows, developer laptops can become extremely sluggish, making basic tasks like compiling, testing, and even checking email like pretty like this. Uh, so Blink makes it easy to get all of those containers from the laptop and into the cloud, freeing up all the local resources which you need and making your laptop very much faster.
Oh, that's awesome.
Uh, Yeah. So like, who are the people who are going to benefit from it? It's basically if you're a developer who regularly runs containers on your lap, Blend will speed up things by running those containers in the cloud without requiring you to change your whole workflow. So basically, whatever I did over here, I'm not gonna change anything. I'm gonna show you a demo of it. I'm not gonna change anything to my workflow. All my Docker files, everything is gonna remain the same. Just the containers, instead of running locally, they are gonna be run in their cloud. If you're a DevOps SRE or developer productivity engineer and have responsibility for providing an amazing development experience to your team, which is gonna be like me. So Blend's Business Edition makes it easy to hire every developer at your company a light and fast development environment, either hosted at their solution or you could even have it set up on your own Kubernetes cluster if you care about security. If you are like in a financial company, people are going to be like, no, we don't want to use anyone else's cluster. We want to build something of our own. So they even have a solution of like helping you out or setting it up on your cluster there. Okay, so yeah, so let's move on to the demo. I'm just gonna close or shut off these running containers. Uh, so it's pretty easy. If you guys want to try it out, uh, we can try it together. This is basically the application. I have just taken it from their example. If you want to go to kelda.io,
Just
um, if you guys want to like test it out, it's pretty easy. You can just go there to this particular URL and then just hit get started. If I have already signed up, if you haven't sign up, just create like a simple, just put in your email and create any other password. If you want to sign up with your GitHub account or Google, whatever you feel comfortable with it, you can also do that. So I'm just gonna sign into my Kelda account, and it's all free right now. They are still in beta version. Uh, you can like test out any of your other Docker Compose files as well. If you have any other your own Docker environments you want to test it out, you could even do that. They are basically testing different use cases for it these days. So they are basically aggregating different data sets, different use cases, different viewpoints, so they can make their application better. Okay.
perfect. This is pretty cool.
So I have I have logged. When you log it, the thing which you have to do is like you could install Blend. I basically used brew install
Mm-hmm.
from there. You could just install Blend. I'm also gonna follow the same setup. I already have Blend, but I'm still gonna run it so that people who are gonna see this video, they review it.
Okay, let me just
I
open
think
my.
it's just gonna take a few minutes for it, so I'm just gonna escape it out. I'm just putting my screen. I'm just gonna go on to the next, which is like the Blend blog. It's just basically it just takes me to their web portal. At the back end, it just generates a cookie and a session for me, and it logs me in. Okay, coming back to my terminal. Now, what I see is what I did before was when I ran my Docker Compose file, my command was Docker Compose up. When I want to use my command is going to be when, oops. Okay, Okay, I'm in the wrong directory. So like you could see the error, it couldn't find any Docker compose file because I'm not in that directory, that particular directory, and then I'm gonna run doing Docker again. So now it's doing the same thing what my Docker compose did. It's basically creating my containers, but it's not gonna create the containers on my environment, on my local environment. Uh, it's gonna create those containers in Kelda's environment, like in their sandbox environment. So now you could see that my app is being served on port 8080. Um, I'm just gonna go like come back and see, okay, my app is still being served. If I exit it out, you could, and I come back, you could see that there's nothing which is being served now. Coming back, like if I wanna like change a couple of things, like let's see, I'm gonna just build it again. So what it's gonna do is like it's once you like clean it out, like you shut off your containers, it's gonna scratch everything which they had in their sandbox environment, and then it's just gonna recreate it again. So it's pretty like easy if you want to like do a lot of like small changes to your code. It's pretty easy. It compiles pretty quickly. They have their own repository like for storing images. So there's a cache all of those things. So it's pretty fast. Okay, it's still being solved, but I want to like change something to my application. What I'm just gonna do is exit out of it. Okay. I'm just gonna come to like just let's maybe change one thing over here. My two this meetup. I come back. I run game pop again. Oops. Same thing. So right now my application was not running, it's still building, that's why I don't see anything. Localhost doesn't solve anything. I see it's creating the Mongo cluster, it has created my application, and I come back, and here's my change. So this basically saves a lot of a lot of CPU, a lot of RAM, a lot of memory, a lot of disk space because it's not running anything on my laptop. It's basically running my whole dev environment in like in their cloud version, in their sandbox, and it basically makes everything pretty smooth. So my laptop is still fine. It's running fast. There's no disruption in my like development time, my testing, and serving my application and all those things. And I don't have to change anything at all. Once I am good that my application looks good, I can just commit my code or like other people, they want to see my code, they can just pull that image. They want to deploy to different environments, like in production, they can just deploy that Docker Compose file. I don't have to change anything at
That's
my end. So yeah, I think that's it from my side.
Herman.
Yeah, this is like I found this tool very cool. People, so if you guys, I mean, sure.
Hello, Herman.
Did you have something?
I'm sorry.
Hey, I have a question.
Evan.
Okay.
Awesome.
Yeah, so hey, I just for context, I work as a data engineer, so whenever I'm using Docker or Docker Compose, I'm trying to spin up like Airflow instances for testing of my local machine. One issue that we run into often, or that I've had to tackle, is spinning up a Docker container or Docker compose with like private packages, like private Python packages that are exclusive to my company's repositories, and installing them directly on a container. So managing the credentials can be really tough. And what I've been doing is like combinations of like make files and storing GitHub token variables only at build, and then just completely using them once the pip installs something and deleting it off the machine. I'm wondering, and like the online resources, no one seems to know how to actually do this the right way. So I'm wondering if you have any insight into how you can integrate the company's private packages in a safe and sophisticated way.
So what in regards to like using Blink or any other one?
Probably not even for Blink. Like imagine you had just like kind of one Docker container and you wanted to pip install a private package that requires private credentials like a secret access key or a GitHub token.
Okay, so that's basically like a functionality of a secrets manager. For that case, you define like a secrets manager. It's basically a service which stores your secrets. Have you used any of them before? Like for example, there's like HashiCorp Vault is there where you define all your secrets. Then there's like AWS has AWS Secrets Manager. So basically, it you create like an endpoint, and then you store all the secrets, and then you just hit that endpoint and then call that.
Oh, okay. So you use kind of like a third-party manager for those credentials.
Yes, that it is basically good for like because then like you just define it and then everyone uses it. If you wanna like just use it like just for your local environment, then I think like basically like if it just impacts you, then just using like the environment variables is like good enough. Like that's how I also do for my local environment. But if it's like the whole team has to use it, then like having like define a secrets manager is a good approach.
Okay. Thanks a lot.
Yeah.
I think I'll look into that.
Yep. Yep.
Hey, Herman.
Cool. Any other questions? You could ask me anything like not related to Blend. It could be anything like any like DevOps stuff, cloud, databases, uh, like like server systems.
I do.
And
Harman, can you hear me well?
yes, I can hear you.
Okay, great. So I'm not even a junior developer. I'm very basic. So
No, you're not.
really fundamental, but I was interested in difference between the virtual machines and containers. So it looks like the containers are like sharing the operating system. So that for the other developers who are working in their local server, even though their operating system is sick or like some problem, like they can still use the main operating system. Am I correct?
Yes.
All right.
So
Mhm.
yeah, go ahead. Go ahead.
Yeah. Hey. So I was imagining this situation because I also have some of the occasions that I need to share the code with the clients, and then all clients are using different types of OS. Some of them are using Linux, some of them are using like a Windows. I am using Mac, like that. So what we were planning was to make use the virtual machine and then make the application or share the codes like separately. But do you, in your with your experience, do you see regarding the all the efficiency, like, and then assuming that some of the clients' the computer might be really bad, their OS will be really bad, or like their capacity will be bad. Like, do you recommend using the containers or like do you recommend using the virtual machines? Because I see a lot of virtual machines are applications like easy applications are available outside.
Are you there?
I think he.
Okay. I mean, I can start talking until he gets back. The farm is definitely the best person to answer that. Andre's actually probably also a good person to answer that.
Sort of give a hat.
All right, you want to start it off?
Yeah, I mean, okay, so when we're talking about virtual machines versus containers, it's important. So, okay, there's a part that I know and a part that I don't. Is that Bruno?
Yeah, I think I love.
Yeah, he's back.
Okay. So, guys, can you see the question again?
Yeah,
Yeah, my.
oh, no problem, no problem. I think the internet is weak. So I was wondering the main difference between the virtual machines and containers, especially in the environment of that you need to share code or whatever that could be with some clients or other developers who are in a like an environment where they have a weak internet and then like a weak OS and then weak like computer CPU or whatever it that do you recommend using the virtual machine approach, or do you recommend to use the containers approach? Because for my team, like we were discussing this matter, and then we found a lot of like a free or like a cheaper virtual machines applications out there. So maybe we thought that that would be a good approach, but if there is a containers which I didn't know, so I wanted to learn from your experience.
Okay, so basically, like what virtual machines can do, containers can also do. What containers can do, virtual machines can also do. Like it's same thing. Uh, for what I have been using it, like in a sense, is that like I have for let me explain it with you for you with an example. For a virtual machine, um, I have to basically define my whole machine. I have to give it like I have to define like my CPU, my memory, my disk space, everything. So I define like okay, there should be like 100 gigs of disk space on this particular virtual machine. Then the memory I wanna give it like 16 gigs of memory, and then like a 4 core CPU. Uh, I can like, and then I have my application. So I have my application. It is running on my virtual machine, and this is like a kernel level thing where how my application gets all those resources to run. So all the virtual machines, it had a thing called supervisor. So supervisor basically keeps on giving you all the resources which the application keeps asking for. So for instance, if my application is asking for like, okay, give me 50 gigs of memory, I want to run it, and then I want like two core of CPU and all of those things. It keeps on giving those resources to that. For containers, what you can do is like when you start using containers, you don't have a supervisor. What you have, the thing is like you deploy your containers, like your application would be sitting on your container, and all your containers are going to be sharing the underlying resource. So going on to like the second step of this example is like for instance, there's one application which wants like 50% of resources. My supervisor on a virtual machine is going to give it, and then like it's going to say, okay, I just want like now second application comes in, it wants like another 25% of resources. Then the third application comes in, it requires 25% of resources, and that's that. Like you you have given out 100% of resources, you don't have anything. Even though your application doesn't use it, it is still gonna like say, okay, I'm just gonna reserve this for myself, even though I'm not gonna use it. So your fourth application doesn't cut. In the case of containers, what it's gonna do is like container one comes in, it says, okay, I need I need 50% of resources. So the underlying machine is gonna say, okay, how many resources you wanna use? You can just take the resources are yours. So the container one, it just uses like 2% of resources. Then I have container, second container, second application comes in. It says I want to use like same resources. So I'm just basically like both of the containers are going to share resources now. Third container comes in, fourth container comes in, fifth, sixth, seven. Now you have seven applications side by side, all of them just sharing resources. So in a case, if I'm just using less resources, you can take it over. In the case of virtual machines, you cannot take over those resources. So that's one benefit of using content. The second benefit is with uh, using containers, your deployment process becomes very easy. Like, for instance, like you just have an image, right? You want to deploy your image, you just create an image tag and you deploy that. Now you want to go to your second version. You just create a new image and compile everything, create an image, and then you move on to that next image. And like when you move on to that next image, you decide, oh no, like my code is breaking. I don't want to use this thing. I want to just roll back to what my previous image was. You could just change the tag and it automatically rolls back to your previous image. In case of virtual machines, it becomes difficult because you have to make a lot of like different code changes. You have to create like new commits if you're using like Git. So you have to change a lot of files, all of those things. So it becomes it becomes more difficult. It takes more time, and when you are working in like high production environments, like each second counts. So that's another thing. Third thing is I would say that people who work with monolith application, they are fine working on virtual machine because you just have one piece of code. You don't like depend on like simple services which require like different resources. It's just one code which is sitting there, and that's the only code which is going to be deployed on that particular virtual machine. If you have microservice architecture, then you are going to use, or you are, like I'll say, like there are going to be like 70 to 75% of people who would be using the containerizing. You could also use virtual machines for that, but then like you have to manage a lot of code differently. You have to manage different repositories. You have to maintain different directories, and that takes a lot of so yeah, does that answer your question?
Yeah, yeah, it's really clear. It's really easy to understand. So I think what I understand is the power and the strength of the container is depending on the container engine that is running behind. So
Yes. Yeah.
Really, then with your experience, like what is the definition of the powerful container engine?
Like the power of the container.
Herman?
Hello?
Come in?
We lost Herman again.
Okay.
Man, for DevOps,
Yeah.
we should have that.
Okay. Okay. Yeah. I'll bring up.
Oh, so hot today. Jesus.
Oh man. Why didn't this happen when I was on a call for production? Would be glad if it happened that time. Okay. Yeah, can you say that again? Like the question?
What was my question was how to make a powerful container engine. Because like what I understand is like we are using, let's say like within the 100%, each application is using the certain percentage that goes until 100%. So if that is the case, like how we can make the powerful container so that we can share it with many applications. What is the
So
measurement that is deciding?
So your container engine is basically going to use the underlying resources of where you like deploy those containers. So if you are deploying those containers, like I was deploying those containers on my laptop, it's going to use all the resources of my laptop. That it's going to keep on sharing the resources of my laptop. And along with that, it's going to like my different applications are going to be also run. Like my browser is running, my Gmail is running, my other like different like tools are running, all of those things. When I deploy it on like a server, it's going to use the underlying resources of that server. So like you could scale your server, you could give it more resources, and then the Docker container like they keep on using those resources. It's basically different in different cases. For instance, like for like in production environments, there are like your database is gonna be like heavily utilized. So you give a lot more resources to that particular machine or that server. So the containers which are running on that, it takes up the like those resources. If you have like least using like if you have a lightweight web server like Apache or Nginx, you could use a like small machine. You could, and the same way, like if you have a lightweight web application, which is just serving your request to your database, it depends on that. Going on to like data engineering and data science teams, those are like they work with like a lot of data. They use like the servers. They are, those teams are the ones which hit the servers really hard. Like a lot of traffic they send because they use high utilization. They do like big stuff. So they basically do a lot of processing. They require a lot more resources, and that's how like you use like you give them like big machines or like big like underlying resources and all.
And if I could add just some small tidbits in terms for you to look up. So if distinguish containers from virtualization too. So there's two types of virtual machines, right? And they both run on what's called a hypervisor, right? So if you have access to your own like hardware, you have your own computer physically there in front of you, you can run what's known as a Type 1 hypervisor. So there's Type 1 and Type 2. Type 1 hypervisor runs instead of the operating system. So normally you get a computer, you install Windows on it, you're happy, you're good to go. But if you want to run multiple operating systems, then you would install this other layer called a hypervisor, where then you would install, or rather, you would run virtual machines on top of that. So on top of that hypervisor, you could have Linux, Windows, another Linux, Fedora, whatever. It doesn't really matter. And that's if you have access to the bare metal. The other one, and basically, like for example, if you spin up an EC2 instance, right? What's happening there is you're running a virtual machine on top of I believe what AWS uses is called the Zen hypervisor. So you're running basically a machine on top of that. That's Type 1 hypervisor. Type 2, which is probably I think what you mentioned before, is you said you found some apps and some other ways of running virtual machines on your computer. Those are called Type 2. So those run and are kind of similar to containers. For example, like if you use VirtualBox, you're using a Type 2 hypervisor. They basically run on top of the operating system. So there's no more hypervisor layer there. It's running on top of the operating system. So it really is a question of like where the abstraction occurs in your stack of operating system, application, hypervisor, etc. So Type 2 runs on top of an existing operating system. And Docker also runs within the kernel of whatever operating system you have. So they're similar in that regard. As to what to use, I mean, Type 2 versus Type 1, you're not going to have access to Type 2 to install your own Type 1 most of the time. Type 2 is there for convenience, but I would argue that Docker is even more convenient than that, just because of all the community that's coalesced around it and the tooling that you're provided to actually deploy your applications. So just some terms there for you to look up and sort of understand and just a little tidbit.
Thank you.
Herman?
Right. Are there any other questions?
I have
Thanks,
one quick silly question. It's like on your day to day, that's what you do all day. Like you just write command lines and.
You broke up there. Can you repeat that?
Yeah.
No, I was asking if on a day to day, like that's pretty much what you do all day. You like on terminal, like on command line, like coding. As a DevOps. Hello? Hello? Hear me? Can you guys hear me?
Man
We hear you, Tom. I think Harmon's out of the question.
Now we hear you.
Okay, Harmon, do that.
Yeah. Can you say the question again? Sorry.
Yeah, sure. No, I was wondering, like, on your day to day, like, as a DevOps, like, that's what you do all day, like, you just deploy containers, like, just anything more into it, like, do you just code on like the terminal or like command lines? Do you have to do anything else besides in terms of coding?
Yeah, like it's a lot of things basically. Like it's just on the like I'll do like a lot of like security stuff, like a lot of like deployment of security tools and policy. I do like DevOps stuff. Like DevOps also has like a lot of like different tools, different languages. Like there's Ansible, Terraform, like Jenkins comes in, and Jenkins you have to code in like the Groovy language if you want to create your Jenkins files. A lot of like Bash to Python scripting to do like automate a lot of different stuff. Then I like also do like from time to time I work on like backend different like building different features for my backend team as well. So like that's like gonna be like 15-20% of my time in a month. I'm building like any backend feature. So that could be like anything related to like doing like some of like data engineering stuff or maybe just doing like some like building something like web application or maybe like writing a microservice, deploying it on my if I want to like take a chunk out of the monolith and just create a microservice, I'm just gonna do that. Then it's a lot of like monitoring stuff, production support, all of those things. Like it's mix of a lot of things. It could be anything.
Okay, cool. It was just curious. Curious. I'm sorry.
configuration languages and like Dockerfile is its own kind of templating language. Docker Compose is its own sort of templating language. Then if you wanted, if your organization
Don't forget Kubernetes.
Kubernetes is its own thing. You have to learn their syntax.
Yeah, that's gonna be one of my lessons, like which I'm gonna like maybe in coming weeks. I decide to do like a Kubernetes. That's also.
You want to formalize your resources as code, the paradigm infrastructure as code that comes off more and more. Then you're going to have to write a bunch of templating language to describe all of the various physical resources or rather virtual resources that you have. And that's like a lot of code to write down if it's not automatically exportable, right, from your cloud environment.
Yep.
it's like an army of microservices that you're dealing with.
Yep. That's true.
The shell
And
script.
then don't forget Kafka is
Oh, Kafka.
Yeah, and then there's huge time sinks where you're dealing with highly complex deployed
production
services.
production systems are down. You gotta fix it. You have like tons of you have 15 microservices. You have no idea which one broke and which is causing errors. So you gotta like look into it, fix it, deploy a patch or something like that, or reach out to the team saying, "Hey, your code is causing issues. Fix it," and then send to me and deploy it or stuff like that.
That's cool.
It's like every day is a new thing.
I see. Yeah, I'm gonna take a look deeper into it because I find it very interesting. More than developer itself. Hello.
Cool. It seems like that about wraps up the topic. So we're at 9 o'clock. We're not going to go through the discussion. The discussion was around kind of developer milestones and kind of different levels, how you should be thinking about coding journey and things like that, which I think is a great topic of discussion. But we're going to kind of so look forward to that. And I want to thank Harmon for kind of leading this presentation. I got 2 texts over the course of the presentation complimenting how knowledgeable you are on the machine. And I just, because we're close friends, I often forget. Like Harmon, like is a legitimate DevOps engineer that has so much experience, and I think we're so grateful to have someone with that much experience here. So I want to thank you again, Harmon, for taking the time. And yeah, and then thank you generally everyone who's kind of showing up and taking the time to listen to us.
Thank you. Bye.
Thank you, Andre.
This is a really good lesson.
Thank
Good
you.
night, everybody.
Good night, everyone.
Thanks. Bye.
Thank you all.
Cool.
Thank you, Herman.